Hi, Maya. Hope you're doing well and you're okay and your sisters are okay. Welcome to Rational Functions. You know what's better than cold club soda? I don't know either. That is good stuff. Trying to think. I think I told you guys this. Somebody. Oh, oh my goodness. Why am I blanking on her name? Blonde girl. She's going out with Jensen last year. Sabrina. She's like, "Can I try one?" Sure. She has a sip, spits it out. She's like, "Tastes like static." That's why we're not friends. Rational function, polynomial in the numerator and the denominator. Denominator cannot equal 0. When sketching, it's good that I kind of taught you yesterday how to sketch. Yeah, this one's easier. Wait, what is this? 16. A whole, and that's literally the mathematical term, a whole, bless you, is when you have a straight line, but there's one part that x cannot equal. It doesn't always have to be a straight line, but that's one example, and you'll see it. But it happens often with canceling. Like let's say you have x squared minus 1 over top of x squared minus 2x plus 1. The x minus 1s from top and bottom will cancel, and you're left with another function. Well, it's canceled, so it's gone, it's out of sight, but from the original equation, you couldn't have that one value, where x equals 1, because that would make the denominator 0. Even if it's canceled, that becomes our point of discontinuity, and I'll show you. It might sound a bit weird, but I will show you. Hey, it's a long weekend coming up. Is everybody excited?
Yep.
Has any of you guys had like kind of stressful conversations about, not stressful, but is your family talking, should we have these people over, those people, like just because of, or should we go there and stuff like that because of COVID? You guys, anybody doing that?
We moved our family Thanksgiving till like earlier in September.
You saw it coming. That's why you moved it? That's cool. Anybody else? Who just walked the wrong way down the hall? Anybody see? Is there an adult in them? Nobody saw. Okay.
Out of the corner of my eye, it looked like Colby's younger brother.
I couldn't tell because there's a bigger person. They're lucky I left my taser at home. Now, in that bottom point where it says plot a few points in each section and connect with a smooth curve, what I mean by section, the reason I have that in little quotes, is you're going to have like your asymptotes. You might just have one asymptote, one vertical, one horizontal. So by the sections, I mean the 4 sections. Because if you have it like this, your curve is going to kind of do this. It's going to, like, who knows on which section. But literally, if you have it in the, say, from your perspective in the top right, if you have one point there, that's all you need. Because it's going to do this. You know what I mean? So you don't need, like, I think the textbook, it shows like plotting like 8 points. when you're getting into all these tiny fractions, it's going to be 1/8, and then it's 1/16, and then it's 1/32. Well, you just need a point to know, make sure you're in the right quadrant. Cool, cool, cool. And you can do more just to make sure, give yourself peace of mind. Does it go that? Yeah, does it go? Okay, good, good. But really, you just need to know where it's going to go. Because we're sketching. When you see the word graph, that means like with technology. We're not using technology, it should be sketching. And when you're sketching, you're going to be a little bit off, and that's okay. All good? Let you write all that down. And then we'll do examples from page 117, like the computer's telling me to do. Does anybody in class know anybody, or, and I don't mean this in a, not making light or anything, but know anyone or family members that had caught coronavirus or anything like that? Know anybody that knows anybody?
No, but my mom, at her work, there was some guy that came in who got it in March, and he's like in his 20s, and he said that he's like fully like recovered,
Yeah.
but it's like
The effects are still there.
Yeah.
It's crazy. Mr. Pinto, I don't know if this is public. I don't think I'm sharing anything secret. Mr. Pinto has lost 2 uncles. He had 2 uncles die from it. They were like, I think in their 50s. Not the kind of textbook stuff you hear, 70s, 80s, whatever. All right, page 117. Actually, and then I'll probably have to undo this. And you're gonna have to look at my bald head. That should work. All right, so I need something to. Oh, how about that? Okay, what did I say? Page 117? 117. Bloop, blop, bloop. Okay. Start with a real hard one. Y equals, so this is example 1. Page, that was a joke, it's not a hard one. 117. Especially consider, I probably gave you the hardest one as an example yesterday. Y equals 4 over x. Y equals 4 over x. You guys want to be able to see it, right? Do you want me to do it on graph paper? No. Okay. All right. You don't need to. It's neater, and I will give you like grids for when you're doing the work. So y equals 4 over x. So on our steps, do one of you have it easier to access? What am I trying to say? Can anybody just see, what were the steps? First thing was find the 0, is that correct? Like find the non-permissible? So x cannot equal 0, right? That wrecks everything. What about the horizontal? How does that one work? Yep, because the x on the bottom is bigger, the degree is bigger on the bottom, so it would be y equals 0. So showing it like this. Like I said, just a hair off the line. Don't do it a lot. Just a hair, so you can see it, especially when it's right on the line. And then we can plot some points. Maybe I'll do a table of values a little bit lower just so we can see. Now, really what I was saying before is like, I want to make up your mind, Morris. Pick a spot here, because wherever the point, if the point comes in this quadrant, it's going to be like this. If I pick a positive x to plug it in, it'll be either be up here or down here. So in this case, let's say x equals 1. So x and y. When x equals 1, y equals 4. So when x equals 1, here's my scale, apparently. When x equals 1, y equals 1, 2, 3, 4. Now, if you want to plot some other ones, just to make sure, like I've seen enough, but also I've done this enough. I know it's going to do this. You're not going to get some weird round thing that way. Like it's going to approach the asymptotes. But if we want to check, I could do x equals 2. When x equals 2, y equals 2. 2 and 2. X equals 3, y equals 4/3. So 1 and 1.3, essentially. 3, so 1, and you can see it. Right?
Yep.
Cool, cool, cool. So you also know there's nothing down here. You can see the way this shape is going. Like if you wanted to do x equals 0.5, just to go a little bit left of our points. If x equals 0.5, 4 divided by 0.5 is 8. So that's like up here somewhere. Smooth curve with a pencil, so you can erase it if you make a mistake. This is like the most stressful part of teaching for me is anytime I try and do a smooth curve with a marker. I could never be like a sniper for more reasons than nerves. Oh, that was the most beautiful thing I've ever done in my life. Look at that. If we had, if you wanted to have extremes of what's beauty and what's like horror, on one side would be this graph, and the other side would be the back of my head. Ah! All right. And anyways, Maya's like, what is going on there? We miss you. We miss you. Hope you're doing well. All right. So now we need to do something on the left side of the origin. So where x is -1, you can probably imagine you'll start to see the relationships that it goes like a this. This is what it's going to be. So I'm just going to continue on my table of values. So if x is -1, y is going to be -4. If x is -2, y is going to be -2. And I think we're seeing a pattern here. So -1, 1, 2, 3, 4, 1, 2, 3, 4. -1 is going to be -4. -1, 1, 2, 3, 4. -2, and it's going to be -2. And so on. You can plot more if you want, but you don't need to. Just follow this curve. Ah, poop. Oh well. Could be worse. Could be teaching English. Just kidding. It's not a bad thing, I'm just not qualified. I can't fit it all on the screen. Ba, ba, ba. Dun, dun. Anyway, are we good? You guys have seen enough? Literally. Are you sure the rash isn't from drug use? Just kidding. That's a terrible joke, and I'm being recorded right now. Okay, moving along. What do we have next? I didn't say that. Deep fakes. Number 2, and they do it on the calculator, which is lazy, because we can't. So, you want me to just keep going? I'll keep going through examples, yeah? Silence implies consent. Example 2, Page 118. Y equals 1 over x minus 3. Y equals 1 over x minus 3. For those of you thinking, this is so easy, then do this. Do this before I do it. I'm doing it slow to kind of explain the steps, etc., etc. Do it. I'm going to keep talking, though. We know that here, x cannot equal +3. Because that would make the denominator 0. Okay, there's gaps there. My gaps kind of ran away, but that's my my vertical asymptote. Horizontal is where? 0. All right, let's do this. So now, again, you have kind of ignore this. This isn't any kind of a barrier. Our dotted lines are the barriers. It's going to go here, here, or here. One of these, 2 of these 4 places. In these places, it's not going to cross the line. So this is probably not the best place to do a table of values, but I started it, so I'm going to finish it. So x, let's just start with 1, 2, 3 on 4. When x is 4, y is going to equal 1. And don't feel that you need to kind of go up by ones. Go up, because you're dealing with fractions, go up with numbers that'll be easier to graph. Like, you don't have to do like 1, well, a half isn't the worst. But like, you don't have to do 7. 1 over, 7 minus 3 is 4. 1/4. Now you're trying to do a quarter. Stick with numbers, that's going to make it easier for you. So when x is 4, 1, 2, 3, 4, y is 1. So we know it's going to be in this quadrant. I could draw it right now, but I'll just pick a couple other numbers real quick. 5 means y is a half, so it's going to be down there. I could do 3.5, so that would be 2. So if I do 3.5, y would equal 2. Again, you don't need to do all these points. I'm just showing you it works. 3 is tons. 3 is tons. 2 is nice. And here we go, here we go, here we go. And the trick, not bad. The trick is as you draw it, it should get closer to the asymptote all the way. See, like here, it's almost starting to be parallel. Like, it's freehand. I'm not going to be sweating you guys for doing stuff like this. But if you did, if you're like something like that, like that's not good. I will call your congressman. You need to. It should be approaching. It should be approaching the asymptotes. So now my guess is it's going to be down here for next parts. When x is -2, -2 minus 3 is 1 over -5. So it's real tiny. So at -2, it's going to be like just like there, even higher up probably. So if I go further, it'll go further. It'll go. Oh, wait a minute. I'm just going to keep going. Something seems weird here all of a sudden. That's why it's not making sense. So at -2, it would be over here. Thank you. So where x equals 2, it would be -1. Thank you. There we go. Yeah, I was thinking something is not right here. Okay. So you can see this pattern emerging. Thank you, Micah. And that is the worst. Don't ever do that. Don't ever do that. I'm trying to angle the arrow closer to the asymptote. This was kind of okay. This is like that's driving with your headlights off or something. I don't know. Anyways, pencil, because then you erase it. Nobody knows. Do you want another? Well, yeah. We need to get to holes and points of discontinuity. So. Can I change the screen? Is everybody staring at this? You shouldn't be, because that was a mistake. All right. Oh, beautiful. This is what I want. Is this the last? Okay, there's two more examples. This is an important one, though, so we'll do this one. So, example 3, page 119. Y equals x squared minus 9 over x minus 3. So factor this. This is x minus 3 times x plus 3, difference of squares, x minus 3. Before we do anything, before we do anything, like with canceling and stuff like that, identify non-permissibles. X cannot equal 3. Then we can cancel that, and it becomes y equals x plus 3. But it has that point of discontinuity. Now this here, this is a straight line. This is a straight line, but it has a hole in it. So, y-intercept is going to be 3. 1, 2, 3. It's going to go through there. And the slope is 1, so bump, 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 should go through there. Now, at when x equals 3, y would be 6. So 1, 2, 3, 1, 2, 3, 4, 5, 6. So right here, I'm not using graph paper, so my lines might be a touch off, but you should be a straight line. Should have a ruler. Does it have everything you need? Does it? Oops. Very important. Prominently marked hole or point of discontinuity. Now this might be a weird thing. It's different. Is this landing okay? Are you guys okay with this? Is this making sense? Yeah? Nothing too crazy? Good.
Have like holes like that when you're doing like examples of the before.
Yeah. Yeah. Like if we had, let's say this is x squared minus 9. Well, let's just say if it was factored, but it also had like I don't know, whatever, x plus 1 over x. Then you're going to have you're going to still have this cancellation, but you're still going to have asymptotes, and then in the curve, you still can't, wherever x equals 3, you can't have that kind of a thing. Yeah. You betcha. And if you were to punch like x squared minus 9 over x minus 3 into Desmos, this is what you get. It's not like there's some alternate way. This is what you get. Do you want one more example, or are you good to go? There's another example in the textbook. We can do it. One more? Okay. If you want to just go, then go. To work. And I'll check. I can't remember if I have extra questions on that little sheet I made. I don't think there is for today, but there might be. Oops, what did I do?
So why would there be like a hole of discontinuity in a graph?
Because that's a non-permissible for the original, like the original function, like f of x, had something in the denominator that could make it, what's the word, Calvin? What? A word, when you have 0 in the denominator, what's the word? Undefined, yes. So if a 3 makes it undefined, or whatever number makes it undefined, that's from the original. Even though it's canceled and you don't see it anymore, the original can't have it. Yeah, it's very, 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 very important from the original. Like tomorrow, yeah, we have school tomorrow, we're going to be doing solving, I think, if I remember correctly. We're going to be doing solving. And so lots of stuff is going to be canceled, blah, 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 blah. And when you solve, it might be x equals either 5 or 7. But in the very beginning, you had x minus 5 and x minus 7 in denominators. Well, then it has no solution. All right. So this is number 4. Thank you for the questions. Ask constantly. Unless it's about my head. I'm very self-conscious right now. Page 120, y equals x over x plus 2. What is the big difference with this one that we haven't kind of done yet?
It has the same degree in the numerator and denominator.
Yes, which means that the asymptote will be, the horizontal asymptote will be not a half, 1. Yeah, it's
Yeah,
the
my bad.
Leading coefficient divided by leading coefficient on top divided by leading coefficient on the bottom. So we know that x cannot equal -2, and the vertical asymptote is y equals 1. Okay, because it's 1 over 1. Everybody sees that? Like if it was 3x over x plus 2, then the horizontal asymptote would be y equals 3. Okay, let's do this. So x cannot equal -2. Whatever. 1, 2, 3, 4, 5. At -2, so and ideally you're going to do these things with the rulers. And they'll look better than that. So you kind of a little bit want to ignore the axes here because those aren't our asymptotes. So don't feel like I did it just with the last question when Micah caught me. I was at the wrong spot for -2. I was treating the asymptote like it was the axes. So just be careful with that. Now we just got to find out where the points are going to go. So with our table of values, let's just start simple. Let's start where x equals 0 for funsies. So x equals 0, which means, the whole thing equals 0 because there's an x on top now. Okay, so we know it's going to go through this. So we know it's going to be down here. Okay, x is -1. When x is -1, it's going to be -1 over 1, which is going to be -1. If we want to do one more, when x is +1, it's 1 over 3. So when x is 1, it's 1 over 3, about there. All 3 dots are different sizes. So you can see where this is going. That's enough. Use a pencil. Not bad. Not smooth. I got a little shaky there. The nerves kicked in. But it's okay. So now a betting man or woman or cat would guess that it's going to go up in this space up here. So let's find out. So we have x, this is 1, 2, 3, where x is -3. So it's going to be -3 over 1, so that's -3. Wait, -3 over -1. -3 over -1 is +3. And then 1, 2, 3. I'm going to pick one more. I'm just going to say -4. So -4. -4 over -2 is +2. And so on. Smooth curve. It's not the worst one. That's how she goes. Are we good? Does that make sense? If you want graph paper, I got lots. I've got a practically untouched stack right here and lots more in my office. So please just come and take if you want. If anybody wants any of these hard copies before I throw them out, you're welcome to them. I'm just going to have a quick look and see if I did assign, if I did put extra questions on here. 3.4, is that what this unit is right now, 3.4? Then, yeah, there's some extra questions. If you want,
We don't have to do them, right?
you don't have to. It's just Sometimes there's a little less kind of in the assignments.
In the textbook, it says the graph is discontinuous because of the break at x equals -2. What does that mean?
You're talking about this one, like,
Yeah,
where does it say that?
like in
There's
the
a third line.
long.
Right up.
Discontinuous. It's just, that's where the asymptote is. Like it doesn't, these two don't connect. Yeah, there's nothing, you don't got to worry about that. You know that there's an asymptote. Like, so these, if there was no asymptote, then these bad boys would connect. It'd be kind of one line. Even if you have x over x, x can't be 0. Still can't divide even 0 by 0. So you would still have a vertical asymptote right at the origin. So just so you know that. And if you wanted, where is it? Like I was saying before, always, you can play on Desmos. It's a good place to let's learn together. And talking about that horizontal asymptote, quicker Desmos, x over x minus 2 is what it was. If I put a 2 here, everything's going to pop up 1. Pop. If I put a 3, pop. Okay, so it's 3 over x. Now if I put a 3 down here, it's going to drop back down. Okay? You can play with this stuff so you get your ideas. All right, friends, I'm going to stop recording. Maya, email me if you got questions, dude. Hope you're feeling better.